Good morning, everyone. We continue to chapter 2, talking about inference about process qualities. So, I hope everyone understand about the word inference. The inference means we are going to give conclusions. We're going to give conclusion about the process quality. The process quality itself, I do hope everyone understand from the chapter 1. We are going to check the quality of the product and evaluation to the process, a whole process qualities. But in these chapters, for chapter 2, we talking about the inference, how you give the inference. Let's say for example, you are going to have a new production in Cambodia, which is one of a popular brand. Let's say Adidas is one of the popular brand, which represented from the another country, their own countries, and then coming to open the new extend factory in Cambodia due to the facility, everything, I mean like labor cost, like policy, everything, and give a good opportunity for Adidas to open in Cambodia. So for the quality code, the whole quality itself, in order to make sure it match and will be compete to the market, and will be match the quality to the market of the Adidas. So the company will going to check the quality of the process, I mean the process quality. Let's say the process quality means we are going to give one of the conclusion that the process doing here is really okay to make the quality match to what they need. So in this, we have a few tools to know to check the qualities. So the first one of the chapters, we are talking about motivation. This is a motivation. Yes. And the second one, we're talking about the estimation. And the third one, we're talking about hypothesis test. The hypothesis test is very important. It's very important that I want everyone pay attention on this point. Motivation is one of the good tools for you to do, to check, to think about, and also the estimation also the best point, because when you're talking about the process checking, you cannot do everything. Like you are doing checking for everything from from 1 until the last lot, the last item. It makes a lot of cost, it makes a lot of time, it means you have to spend a lot of money to check all the production. So estimation is one of the best. Why the best? Because from the estimation, you can give the conclusion. The estimation means you take some sample from the lot side, Sample, the estimate means sample that you want from the lot side, This is a sample size. This is a sample size from the lot side. So from the sample size, you can do evaluation on the whole process qualities. All the whole process quality. That is pretty much critical for this point. You have to do properly. You have to do carefully. The word is you have to make everything random. I mean, before you took the sample, you have to think about the sample must be random. Okay. So hypothesis testing is also last I mentioned earlier. It's very good. So you have to pay attention on this point. Okay, together. So let's check. So the first point, we're talking about the statistic inference. Your statistical inference, the first point. This is a statistical. Okay, the statistical inference. So the parameter from the statistical qualities, the probability distributed. So the probability is distributed is used to model some quality characteristics. Okay, used to model the quality characteristic. This is one that we are going to talk about. Yeah, we are going to talk about the process quality characteristic. Yes. So the probability distributed. You understand the probability distributed. The distribution, normally we have two distribution is the main. One is continuous distribution, we call continuous distribution. And the second one we call discrete distribution. Discrete distribution, yeah. And we call discrete distribution. Continuous distribution and discrete distribution we already mentioned in the first chapters. So in here, the parameter probability distribution are unknown. I mean, because we are want to make sure the quality will be respect to the normal distribution with sigma and variance, with sigma mean and variance, sigma with sigma square covariance and the mean mu. So these two parameters we don't know. That's why they said the don't know. Only the process estimate parameter that we know. The process estimate parameter we know. It means that we're going to consider about the estimation that mu will equivalent to mu square, or we call x bar, and variance we can estimate to as like this. Okay, both presented the we mean and variance same, but there are two are very different. One is from the population and another one from the sample size. So hope you guys remember just two parameters is most important. So here, so the parameter of the process can be time to time varying that I mentioned earlier. From time to time is varying. How to do to identify the process change? So how to do the whenever the process have been conducted for a long time, or we are located in different country, in different factory, we want to make sure the process quality is keep maintained. So that's why we want to do testing. The test hypothesis testing is the most important from you guys to understand about this. Okay, so let's say from the statistic. The statistic here, looking to the normal graph. Looking to this normal graph, okay? This normal graph. Okay, pay attention on this one. We from the population. So here the normal graph, whenever we are talking about the mean, is the median. Mu and median. Median variance and mean. These two words is normally might a little bit confusing if you don't remember. This is mean. This is mean. This is standard deviations. Okay? This is mean. This is standard deviation. When you do estimate, I'm going to drawing down here. When you do an estimate, so some certain process, you will conduct. You will construct another normal graph by using the samples. So the sample, let's say you have a few samples, x1, x2, x3. This is the sample size you are going to take in, or you are going to draw from the population size, and from your log size. So from the sample size, very, very useful to give one of the conclusion, to check on the process quality, to check on the process mean, to check on the process variance of the product. I mean, when you do, we have to calculate x bar, and we have to calculate standard deviations. We have to calculate these two parameters, the most important for estimation their process qualities. Yeah, this is called the estimation point. Okay, so from the point estimation, the keyword that you are going to consider is random. It is random. Okay, the keyword. So the sample that going to taken from the sample, the lot size must be properly random. So here we also have the word random sample. I mean, I independently and identically distributed. We call in the shortcut word IDD. So next, some terminology and definitions that are going to use for this one. You have the point estimation. Focusing on the point estimation. Yes, here, something here. Okay. Point estimation. I don't want to omit all this kind of graph. Yeah. Yeah, you have to check about the point estimation. I mean the point. So second one, the interval estimation. Interval estimation. It's two things. Point means you are talking about one point. Let's say for mean, let's say for medium, let's say for 60 percentile, let's say for 90 percentile. This is a point estimation. But interval means in between one we're talking about it statistically. Normally, every people understand the interval. Interval from the process quality. Normally, when we will be talking about 90%, we're talking about 3 sigma, we're talking about 2 sigma, we talk 1 sigma, or 4 sigma, and let's say the 6 sigma. 6 sigma. From the graph we are representing, normally 1 sigma will represent 60% confidence interval. 2 sigma will represent 95 confidence interval. And 6 sigma normally represent 95.7% interval. This is the interval mean. So one you talking about interval, we're talking about low control limit and upper control limit. Low control limit, upper control limit, mean. This is the interval. So what the point is, we normally want to check these two interval. Okay. So in here, we're talking about the point estimation. We're talking about point estimation. The second parameter, the second point of our objective of the chapters as well. From the three distribution I mentioned here, one is normal distribution, binomial distribution, and partial distribution. So then I'm going to delete that. Delete this one. Delete this one. Okay. Now delete this one. Yes. We continues. Here we have distribution for normal distribution. Normal distribution for another one for binomial distribution. And the last one for partial distribution. Both is continuous distribution. Continuous distribution. It's continuous distribution. From the point, the parameter we're going to show you for normal distribution, we did nothing strange for you because we have mu and variance. This is very simple. Mu and variance. The binomial distribution, we have many times study about the binomial distribution. Normally we talking about probabilities of success and probability of failure. This is the probability of success, probability and probability of failures. We have two things. One, the probability of success means success, and probability of failure. Okay, success and failures. So P is normally going to estimate it. Is going to estimate it to P's, and this one also going to estimate it. Yes, and S squared. is going to estimate it. As well for the Poisson distribution, you're going to check, you also have seen before is a lambda, is one parameter, and also going to check it. Okay, going to estimate it. So this some distribution that you are familiar before, but normal distribution is one of the distribution that we're going to use the most. Okay, so the interval that here, the interval here, normally is this is the gap in between of upper and lower control limit. Upper and lower control limit. So the interval we are going to conduct in with 3, 6. One is about lower. Second is the upper control limit. And the third one is mean. Okay, so representing lower control limit, representing upper control limit, and representing means. So this 2 is the 3 is 1 after 1, 4 the normal graph. Okay. And from the lecture, we going to calculate the interval. This interval. Going to calculate this interval. So this interval is going to be 100% of 1 minus alphas. So this alpha is the most important that we are going to talk about. This alpha is a significant level. Okay, this is a significant level. Normally alpha, this is representative. This is alpha representative. And one side we call alpha over 2, and the other side we call alpha over 2 as well. So both sides is a significant level. Both sides is a significant level. So hope you guys will pay attention on this. One side, both sides, one side upper level, one lower. So from these two sides, confident interval we call side is 1. We call confident interval we call CI. Okay, we call CI. So confident interval, normally we can say, mentioned earlier, the confident interval of the CI of the 3 sigma is about 99.7%. The confidence of the 2 sigma is about 95%. This is the confident interval. It means from the C sigma, the significant level alpha is going to be 0.3%, the 1.37. And for the 95% is about 5%. This is the significant level, we call significant level. From both sides, the one side is, from this one is 2.5, this is 2.5. So hope you can understand that as well. Okay. So continues. So to underline the procedure. From this point, we have some procedure to underline. First one, we need to get a sample. So from this one, we have to get a sample. So the sample is going to be here. So let's say this is a sample. So we have x1, x2, blah blah, and then xn. The second one, we need to compute statistics, computing. So we need to have x bar, okay? Standard deviation is the most important as well. So another parameter like mean, medium, like mean, medium, this is also important. So the third one is going to do the statistic inference distributive, and we call inference distributive reference distributive statistic. And the third one, the last part of the first one is select the confidence interval, I mean the confidence level. Okay. And the last one is this one, if find the lower and lower control limit and upper control limit. This is the most important. And next, this is some procedure. First one, we need to find x1 bar, x2 bar, x3 bar. This is the samples. This is you have to find the sample. And lower control limit and upper control limit, we need to calculate from the above. I'm going to give you the formula letters. Okay. So how to determine the width? This is what we are going to calculate the upper and lower control limit itself. So these two very important. These two very important. Okay. So we are confused. Yeah. Everything mess. Huh? Hope you guys understand. Okay. So we start continuous from the X part. From the X part. Is the submission, normally this is the very simple formulas. It's a submission of xe, e from 1 to n, over n. This is very simple. This is how to calculate the X bars. Okay, how to calculate X bars. So here, let's say you do alpha level. Okay, let's say you do alpha level. Since alpha is a significant level, we call alpha level. I'm going to alpha level. So from the alpha level and from the X bar, we do estimation the interval from. We do estimation the upper control limit, and lower control limit. Okay, lower control limit. So let's check the formula I'm written to you. So over 2 is sigma over n, biggest and smallest and mu. X bar plus z alpha over 2 and sigma okay over x. So this is the length. This is the length. This is the length. This is called the lower control limit. This is called the upper control limit. So what we need to do the estimation? Because what? Because we don't know exactly what the mean is. That's why we have to do estimation and check whether it is inside or outside. Inside or outside, we have to base on the graph. Okay? Inside or outside, we have to base on this graph. This is inside the interval. Is interval or outside here. Okay? This is what our purpose in the check. So please pay attention and be care, be careful on this. This is lower, this is upper. Okay. And the rest two for the confident upper confident interval is here, and the lower confident interval is here. Yeah, the same. So the point is we are going to find z. We are going to find z. This is the both sides. I need to point to you. This is we call both sides. There are two sides. Two sides. We have two side confident interval. Okay? Okay, two side confident interval. So we also have one side confident interval. We can have lower side and upper side. But remember, if you're talking about one size, we have upper. So z must be alpha, not alpha over 2, because we are only talking about one size. Let's say one side here. Okay? Let's say 1.5. And lower side is lower side this side, upper side this side. So must remember, one side, upper and lower, must be Z alpha, not Z alpha over 2. Z alpha over 2, it means both sides. Both sides. Okay, we also have one. I'm do this example to let you guys understand about one side and two sides. One side, two sides continuous interval. This study is going to show example. Okay. The example of this one, the spring of the disposable plastic beverage contained in being investigated. The spring are not more distributed with the unknown standard deviation with the known standard deviation is 1/5. That means if you want 5 PSI, this is, and there are 20 samples. Mean n is 20. Okay, n is 20, and the plastic container has the mean strength. So from the sample, we got X bar 246 psi. Okay, 200. They need to compute. They ask you to compute 95 confidence interval. In this term, you have to find the interval. Mean you have to find upper and lower control limit. Let's say you have to find here. What is here and what is here? The upper and lower. From the formula given lesson earlier, x bar minus z over 2. Okay, here we're talking about these formulas. Sigma over n smaller or bigger than v. It is x bar minus plus z alpha over 2 sigma over n. Yes, definition. You have to. This is alpha over 2. We need to find because 95 confidence interval. It must be alpha equal 5%. So alpha over 2 is 2.5%. So for 2.5%, we need to find z 2.5%. Where is it? Z 2.5%. So I will show you in the graph, normal graph. Okay. Okay. Here, this is very important. So from the normal graph, you have to understand this is one side. So in case you are looking for this one, 2.25, 2.5. That means 0.025. 0.0 from the normal graph, you have to find from 0.025. This is the one side normal graph. So if you want to find the lower side, you need to consider the upper side because it will be equivalent, yeah, from one side, from the upper side and the lower side. So regarding to this point, you normally have to find 0.975 is the most important. So if this value Z must give you one value, so the another value will be another size, one side each. Okay, one side each. Thinking about this one. This is the median, this is 0. This is 0, this one the minus part, this is the plus part. So you are going to check it. You're going to check this somewhere in here. Okay, you're going to check. In this one, so the value is going to return. The value is going to return somewhere here. Good value is going to return. Maybe you can return from the graph is 0.049. This is Z equal 1.64. 1.61, and the another one is Z 1.6y 0.0. Oh, sorry. This one is the exact value that we're going to check. 0.9750. Z is here. Is 1.96. 1.96. Okay. 1.96. Yeah, that's correct. Also, this value is going to be 1.96. You can just for doing calculation and that's it. Sigma already told, N already existed, and X bar already existed. So no matter, this is pretty easy to do for you to calculate. So hope you guys understand from the daily example of how to calculate the intervals. In this another example, please do it at home. Please do it at home.